Hey guys, welcome back. In this one, we are going to swap out. Well, I'm going to show you two methods. One we already did, which is the root motion system, and with this, it requires extensive knowledge on how to modify this system, which could be pretty difficult for beginners. So I'm going to switch this across to a more common method, and that is using the default velocity based movement input system. So what we're going to do is right click and we're going to search get control rotation. You won't get it in the component, so what you need to do is, since the target is pawn, if you recall, the pawn target derives from the instigator, so let's get instigator, and then we will get control rotation. We want to split the control rotation, and from here we get the forward vector. Well, we can, yeah, so let's do it before we split the pin. So let's get the forward vector. We're going to break this and split both pins. For our forward, we'll use this. So this will be our forward direction. And we want to not duplicate, but we need to get the right vector as well. So I'm going to recombine the struct pin and get the right vector. So we can delete this now. And we want to split the in rotation. So for this one, we connect the X, which is roll, and the yaw. Now, we need to add the movement input. So for forward, we add movement input, duplicate this, and for right, we add movement input as well. We need to get the instigator again. Since the target of these two movement input nodes is pawn, we drag in the instigator for both of them. And now let's collapse this to a function. You can see we have this error. This is because a function can't have multiple input execution pins. So what I'm going to do is just connect this here. And now I can collapse it to a function. I'm going to call this add velocity input. I'm going to open it up. Now we can disconnect this. Add a branch. Oh, add a branch. Connect it here. And drag the condition to the input of the function. We're going to call this forward question mark. And if forward is true, then we use the forward movement input. And if forward is false, then we will be using the right. One more thing we need is an axis value, so a scale value for the movement input nodes. So select your input of the function, create an input of type float, and we're going to call this axis value. Right click and we're going to search for get axis value that we just created. And we want to plug this up into the scale value of both of these functions. We compile and save. Head back to the event graph, and we need to do one more thing. Well, we can disconnect this if you want, and if you want to keep this, you can, but I'm going to disconnect it since I'm going to be showing you this new method. Put this aside. Let's leave a comment, not in use. Root motion. Great. So I'm going to duplicate this function here. And for forward, then we set forward to be true and plug in the scale value. For this one, forward is false, which means we're right and left, and plug in the scale value as well. Compile and save. Now if I try to hit play, you can see, again, nothing happens. And this is because in our ABP combat, we are updating these values here. So we can disconnect this, hit compile, and in our class defaults, change the root motion mode from root motion to everything, and we're going to reset this to root motion from montages only. Compile, save. Now I should be able to slide around. And as you can see, he's turning to whatever direction that we press. So if it's left, he's turning left, right, he turn right, and so on. So that's all for this side. Let's update the animation blueprint. So again, I'm going to disconnect this and move it aside. Root motion not in use. Great. So we'll still need the combat components to update the combat enabled variable, but we'll need a few things first. So from the try get point owner, actually let's do an event blueprint begin play, and we want to cast to character, and we're going to duplicate the try get point owner here, and this will be our object for our cast, and I'm going to promote the as character to a variable. Simply going to call this character. From the character, we want to get the character movement component and promote this to a variable as well. Now we have access to character variables like data, stuff like that, and we have the character movement component reference as well, so we can get all of the character movement components data. So I'm going to delete this, and I'm going to get my character reference variable, right click and convert it to a validated get. And only if the character is valid, then we will update the animation blueprint. So from the character movement, we want to get the velocity. From the velocity, we want to get the length, vector length, and promote the return value to a variable, and we're going to call this speed. Oh, so I already have a speed variable here. This is from testing, but you can promote it to a variable and name it speed. So set that variable. Compile, save. Let's do if speed. How do I do this? Okay, so let's get the acceleration, the current acceleration. From the current acceleration, we want to check if it's not equal to 0 and if the speed is greater than 0. We can do something like 2. Speed is greater than 2. And if both of these conditions return true, then we promote this to a variable, and we're going to call this should move. Great. So in our anim graph, we won't need these two. So I'm going to pull this aside. Root motion not in use. We need to update the combat enabled variable again. So I'm going to copy this and this, get in here. And before I forget, we need to ensure that the character movement, not the character movement, the combat component is valid as well. So I'm just going to bring all of this aside. So if the character is valid and if the combat component is valid as well, only then can we proceed. Update the combat enabled variable. so this can update in real time and update the animation blueprint. Now we are currently at A pose, but again, we can move around. And if I try to equip the weapon, he still will and play the montage because we are using root motion from montages only. Right, so next, what can we do? Yeah, so let's create a state machine. I'm going to call this unarmed state. Now if combat enable is false, then we update the unarmed state. So I'm going to open this up. I'm going to drag off of the entry pin and we're going to add a state. I want to call this idle. Open it up and we need to get our idle animation, our unarmed idle. If I hit compile now, he would be in the idle state. If I hit play, he will just be sliding around in his idle state. So we're going to drag off of idle, off the edge here, and we're going to release, and we're going to add a new state. And we're going to call this walk. Let's call it movement. I'm going to open up this transition, and we need to drag in our should move variable. And that is all. He would enter the movement state. So if I hit play, he's currently idle, but if I push forward, he will enter the A pose, as you can see here. And we need to transition back to idle, which we'll do now. The only thing we need to do is open it up, get our should move variable, and check if it's not true, and connect it to the transition. Compile save. So now he will enter the A pose and back to the idle. Great. So for the movement, we need to create a blend space. So in my combat system folder, right click, create a new blend space. 1D. Select your skeleton, and we're going to rename this to BS underscore unarmed. Unarmed. Simple. Sure, why not? The horizontal axis, we're going to rename this to be speed. The value will be between 0 and, let's say, 450. We're going to snap the grid. The smoothing time, we're going to set it to 0.01. And the weight speed is going to be 5. So since this is the unarmed blend space, all we need to do is get our unarmed animations for walking. So walk forward. We're going to place this at 112.5. We're going to place it at 0. And for our running, we're going to place this at let's place it at 450. Actually, I'm thinking I'm going to make this a bit slower. So I'm going to delete all of this and set the maximum axis value to be 375. So for running, will be 375. For walking, would be at 112. Great. So in ABP combat, in our unarmed state, in our movement state, we're going to search for our blend space. So BS unarmed simple. And all we need is the speed variable. Now, if I hit play, I would be able to enter the jogging state just fine. And this is because he enters the jogging state instantly because we are using a default max walk speed of 500. So if I set my max walk speed to the value that we have, which is 112.5, and I hit play, he would now be walking. So for me, I'm going to leave it as running, so 375, and he will now be running at the speed that I specified, which looks pretty good. I'm going to duplicate this blend space for unarmed simple. And I'm going to rename this to be combat simple. And the only thing we need to do is replace the animations. So run forward and walk forward. Save. In AVP combat again, we need to duplicate this unarmed state machine. I'm going to call this combat state. Plug it up to true. Open it up. For our idle animation, we just need to search for idle and get our combat idle animation. For movement, we just simply need to replace the blend space with combat simple. Compile and save. And now if I toggle combat, I can use my combat simple blend space. I can attack, and everything works just fine. So the next thing you may notice is that the combat is a bit stiff, so he can only attack in one direction as long as you're left clicking. So in the next video, I'm going to show you how to update this so you can attack in the desired direction based on your button input. So if it's A and you're switching to S, let's say for example, he will automatically turn to face the direction that you're attacking. So that's it for this one, guys. See ya.